Hello, my name is Jakub Kocikowski, and I'm a product manager for Aleph Zero. And today I wanted to talk to you about how to achieve fair voting systems. First, I came up with this very broad topic, but I thought that I need to focus on something, and I chose voting for two reasons. The first one is that voting seems like a very basic building block for any kind of organization that would run in a decentralized way. So any kind of DAO that is working on-chain, their main reason to exist is to take decisions about something. So voting is kind of creating a system that is fair to make decisions is an underlying kind of problem to solve for the decentralized organizations. And the second reason is that voting, the problems that we solve trying to achieve the fair voting systems are the same problems that we would face in any other applications on public blockchain. So where do we use voting today in blockchain? This is DAOs. We're trying to take decisions about protocols, where they will go in the future, under what parameters will they operate, or we are trying to take decisions about shared pools of money to give as grants to different projects or as investments. So in this type of organizations, we can think of two things that we might want to protect, the two things that we might want to keep private. And that is state and actions, which means basically the transfers that are coming in to the pool, or like the interactions that others are, people will be having interactions with your DAO, so you might want to keep them private. So we don't know who is interacting with the organization. We might want to keep private what the DAO who is the DAO interacting with, or we can want to keep private what amount of money or like assets does the DAO manage at the given moment in time. So that is the first point, and the second point is the decision making. So the voting process that we will be focusing on today. So before we go further, I want to introduce you to the Shielder. The Shielder will be like a basic building block that we will be using for solving the problems that I will define in a moment. And what Shielder is, from the perspective of the user, is a black box. So like a privacy black box. So I can, as a user, I can deposit some amount of assets into the black box, and after a period of time, I can withdraw it to a different account, and these two transactions shouldn't be linked together. So I can deposit them to the black box, withdraw them to a different account, and publicly, you will not know that these assets on the second account are still my assets. We're removing the link between these two operations. So I think it might be pretty clear how we can use it to solve this first problem of the DAO. So if I would want to deposit some amount of assets into the DAO smart contract, I could just put these assets first into the black box, the privacy land, and then withdraw it to a different account, therefore like removing the link between me and the transaction that is going into the DAO. Yeah, so this is the basic building block. I will not talk too much about like technical parts and encryption and cryptography that goes on behind it today. So we'll just keep it simple. And for now, our Shielder is just this black box, but we're working on another product called Liminal, which will be able to keep smart contract state private and any transaction allow for transactions within the privacy land as well. So with that in mind, let's move to another slide. How does voting work right now on a public blockchain? We usually will have a couple of actors that will have some tokens that will represent their voting rights. And they will send these tokens to a smart contract that will count votes for different options that we are choosing from and take a decision afterwards. So what is the problem with this approach? First problem is the influence. So let's imagine that Alice that we will be voting between two options, and let's say that this is a vote in protocol DAO, and we are trying to decide something important about where the protocol will be going in the future. It could be how high the fees should be, what kind of or anything else about the protocol that might be important to decide on. So Alice, in this scenario, will be a big investment company that has a big stake into that their decision will go in a certain way. And what will happen that people that might want to interact with Alice, they want to work with them, like for example Bob on this slide, they will be influenced by Alice voting a certain way to follow with the same decision. So Bob here would prefer to choose the second option, but because Alice is voting for the first one, Bob will also vote it. And in this simplified example, we see that the decision was changed because of the influence that Alice had on Bob. We don't want that. So how do we solve it? We use the shielder, obviously. So before the votes are cast, the participants will move their tokens inside of the shielder, therefore like removing the connection between the vote that is cast and who is actually placing the vote. So in this scenario now, you see that the vote that has been cast, you see the decision, but you don't know who exactly voted for which decision. And Alice will not be able to look at the vote, what Bob did and say, you voted against my options, therefore I will not be working with you. And I'm not saying that any investment company would actually do it intentionally, but that might be not intentional, that people might look at other decisions taken by other people and get inspiration from them. So that this is a problem. Second problem that this solution doesn't solve yet is backrunning. So what is backrunning? So let's take this example. We will be taking a decision between three options, A, B, and C, and we'll have a couple of actors. Alice, her first preference is to vote for an option C. But if she cannot get C, she would prefer to get an A. Bob, on the other hand, also would like to vote for a C, but his second preference is a B. And then we have a couple of other people that will be voting equally between the A and B. So what happens is Alice is very eager. It is a very important topic for her. So she will vote as soon as the voting is available. So she will cast a vote based on her first preference. So she's voting for C. After some Bob, on the other hand, will wait to get as much information as he can before he casts his vote. So some time has passed, and everyone else cast their vote. So in this scenario, Bob is the last person to place a vote. So how will he vote? Will he vote for C? Obviously not, because in this moment, C is not going to win. So his vote will be lost if he will vote for C. So obviously, he will vote for a B. But he changed his decision because he had way more information than Alice had when she was voting. So because of that, the vote that Bob had changed the decision and had way more influence on the voting than Alice, but they had the same voting power. So what happened? Like, why? That is a problem, right? We don't want that. So how do we solve it? Well, we can move the smart contract, the counting of the votes inside of the shielder wall. In this moment, we will not know who is voting for which option, but also we will not know, we will only know the decision and the votes that have been cast at the end of the voting time. So as long as the voting hasn't finished, all of the actors will have the same information. So backrunning is not possible. This solution actually solves another problem, which is problem with specific voting powers. So this problem goes like this. we have actors, we have voting where everyone can have a different voting power that can be based on stake or amount of governance tokens that they have or any other reason. So in this case, Alice has a different voting power than all the other participants. So when she casting her vote, we see that the voting power, all of them are using Shielder. But because the transfer that is coming from the Shielder to the smart contract will have voting power that will be public. So we can say for certain that Alice was voting for X. So we're de-anonymizing Alice in this case, and we don't want that. If we want to keep things private, we want to make sure that they're private in every case. So if we move the smart contract that calculates the votes inside of the Shielder, then we can publish only the aggregate of the votes. So in a big number of participants, we will not be able to decipher who is voting for which option, or we can even skip that and only publish the decision, removing any possibility to de-anonymize the participants. So in conclusion, voting has three major problems, which is influence, because I can see what you're doing on the chain, or I can be influenced because I'm looking at what you're doing in the blockchain. Backrunning, which is using time and more information that I can gather to influence decisions, as well as the anonymization of what my preferences, what I'm voting for if I have a specific voting power. And I think all these four problems can be fixed with privacy solutions designed specifically for blockchain. And I think it is, these three problems will also matter in other customer applications like trading, for example, or anything else that you would want to do on the blockchain. Yeah, that is it from me. So thank you for listening. And are there any questions? So for now, it's still in development, but the idea is that the Shielder will be a solution as a privacy as a service, and through bridges and other connections between chains, you would be able to use this privacy solution with any other project that it is connected to. There's a question there.
I guess, do you know Noun's project? They were doing private voting requests for proposals. Did you propose something for them?
Can you repeat the question? I didn't understand, sorry.
There was a Noun's DAO which asked to propose privacy voting solutions for them. Did you make a proposal for them?
I'm not sure.
Okay, yeah, that's it.
All right. Thank you very much. I will move to the next slide. Thank you.